Hello, on this third day of lectures, or second day of lectures. First of all, thank you very much for the invitation to once again present at the Russian Summer School of Institutional Analysis. This is not the most important lecture. It's not as funny as also Michael's. It's just one technique that I had to use at one point in time to make my research more credible, and it seems to be very fancy and also applicable to other research. So the idea today is to show textual analysis for hypothesis testing. I will give you a variety of examples. This is not the complete world of examples, and because you are younger and probably with a high probability much better than me in coding, you will be able to learn it fast and apply to your research. So first, I'm not going to deal with your hypothesis. This is something you have to work on. I'm not going to teach you how to merge with other data sets. This you should learn how to do, or you already know. But I'm going to help you in how to gather data, prepare text, and analyze large quantities of data just to test hypotheses, merge with other data.
I'm going to teach you how to get a lot of money to do it as well.
It's almost for free. All the software is for free. You have to invest time. That's true, you have to invest time. But all other stuff, at least the one that I'm going to talk about, is very cheap to get. For instance, you can scan documents, going to the library and taking pictures. And from that picture, you can get text. Or you can crawl the web. This is for free. Other ways of calling textual analysis, you may have heard about algorithmic data reading or natural language processing, computational linguistics. It's all the same. If there are some differences, at least I don't know. But anytime you hear one of these one of these topics, it relates to textual analysis. Analysis of large quantities of text. Why it is becoming most popular? Of course, we have faster computers, so in the past it was not able to process that much. The era of big data, now everything is on internet, so it's accessible. And we also have better engines to download data. So this is why there's an explosion in textual analysis. It's not that previously it was not done. It was done by very educated people that were called scholars, and they were reading in libraries. And then they were writing papers about it. Now what we are trying to do is somehow automatize that process to facilitate the analysis of so many material that is impossible for one person to read. So in one research, for instance, I processed 200,000 contracts, and the amount of words is equal to 1,000 times crime and punishment. So you can read crime and punishment 1,000 times or equally, and that is more or less what time it would get you to read all these contracts. Or you can process it in a machine way, so you just distill what you need from that material. The software, there are already software prepared for that analysis. For instance, Worstat, Lexactilix, Diction. I have never used them. You can code yourself in languages that are available, modern languages that are available. I recommend Python. So today my examples are going to go to Python, and again, Python is for free. So you can download all the libraries. Many of the software is already prepared, so some of the steps you have to take are like packages that you can install and just run the package to stem text, for instance. So now into the first step, data gathering. What do we mean by data gathering? If we have to analyze, again, we start with a hypothesis. This is not the first step. First, we have to have a hypothesis. Because many people think, oh, I have this amount of documents, let's do something, without having a prior hypothesis. So I assume that we already have a strong hypothesis that we want to test. It's not that I have documents, let's do something. Let's just data mine and something will come up. No, first we have the hypothesis. But once we have a hypothesis, we look into the documents. How do we gather documents? So documents that can be used as source data could be, for instance, law and court decisions, political speeches. I will show you some examples here. Contracts and regulations, company filings. I don't know about the Russian Federation, but in America, all companies are obliged to file 4 times a year, something called the 10Qs, 3 times a year, once a year, the 10Ks, and anytime there is a news or something important, 8Ks are the documents. But these are textual documents. There are in a server at the Stock and Exchange Commission. They are downloadable, but then you have to analyze them. Of course, if you analyze one company, it's easy. You just read the 10Ks of that company. But if you have thousands of companies and you want to make a comparison between the companies, how managers express their sentiment in those texts, how they analyze not only the number, what is the profit, what do they say about the profit, how do they see the future. This is what we are trying to get. Audio transcripts. So many US companies have conference calls with their shareholders. And these are conference calls that you can join. But then you have the text, and you can analyze. You cannot be in all conference calls at once, but you can analyze the text, so the transcripts. News and media reports, websites, social media. Now there is tons of research going into your comment about a restaurant. Well, it's not just your comment and somebody else reading that comment. Companies use advanced software. Well, advanced. It's not that advanced. You can do it yourself. But there are machines that try to understand what is the sentiment of the consumers that went to that restaurant. The idea is we have to have a homogeneous textual corpus. We cannot get social media together with laws. That would be like a soup, not very edible. We have to have some corpus because the hypothesis is one. Now we need a corpus that is homogeneous in addressing that hypothesis. Also, we can, from those documents, we can scan them and OCR. This is translated to text. And the software is already there. So if you have pictures or PDFs that are not readable, the software today is so good that if there is a spelling mistake, it's probably that the spelling mistake is in the original and not in the translation from the picture to text. So if you have a spelling mistake in the text that is later on, most probably is a mistake in the original text than in the OCR. The advanced software absolutely is. Web crawling and scraping, so you can go into the text, into the web and download, and use ready libraries. A ready library is most of US law, for instance, and I guess in Russia as well, is already in a text format. So you don't have to translate into text. They're ready in a very systematized way. Once we have the data, now we gather our data. We have our files, we have our libraries, we have our scans. What do? We have to prepare the text. The machine is still a little bit stupid. We are smarter. This is not what is Terminator 5, when the machines are more intelligent. Still, we are not there. So what are the steps? Typical step is to clean up the text. So first, many of the downloadable formats from the web, and also if we use one of these free libraries to translate from PDF to text, we may get tons of coding inside. So here's a table or some graphs, markups in HTML. So we have to clean them all because that's not text. That's something for to put in the web, but it's not text. We have to re-encode some of the references. Also, we need to stem. Stem is to get to the root of the word. So, for instance, expensive, expense, expensing are many words, but relating to the same thing. Stemming is getting the root of the word, the expense. And if I'm looking to words related to expenses, I don't want to count 3 times different words. I want just the stem. Also, to avoid inflections. So this is, all these steps can be done automatically. So there are libraries ready. When I call in libraries, it's a little program that you can run from your main program. So you run that program, and that program yields you already the stamped text. Another very important thing, and I'm just going to signal, is regular expressions. When you do textual analysis, this is like the prima ballerina of textual analysis. Regular expressions, or regex, is how you identify pieces of text that have a particular format. And by that, I mean, for instance, if I'm looking for a number, a 4-digit number, I put a /d, 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 and that would identify any sequence of 4 numbers. If I'm looking for any number of any length, I put /d in Python, /d+. So that would yield a vector with all the numbers that are in that text. If I'm looking for the word Super Marian plus a number, what is my grade? That would be Super Marian / or one space /s /d+, because looking for any number after Super Marian. The idea is you can get any regularity, any word that is in the environment of 10 words, for instance, or any number, you can get a price. You have a text, you don't know the price, but you know the price is going to be in dollars. So I'm looking for the word dollar, and then in an environment of 2 words, for a number. Then I create a vector of all the numbers and look for the higher one, because probably the price is going to be the higher number of that vector. And from a plain text, I get the number. There may be some mistakes, some false positives, but the idea is that you narrow down pretty much to something that is very likely to be the price in that text. So we can identify numbers, prices, word environments. Regular expressions. So that is going to be your main tool, probably, in textual analysis. Third step. So we gather the data, we clean them up. Now certain techniques. And I'm going to show you 8 examples related to 4 techniques. And I'm not arguing that this is the whole world of techniques. These are very simple ones, and these are the ones I use and I know. So the first one is dictionaries. A dictionary is something by which you teach the computer how to do something. The same way we learn a language. How do I learn Russian if I had to learn? Well, probably the first thing I would do is to buy a dictionary, or to have an online dictionary, to translate. So here is how we teach the computer that this word means something. In finance, the big guys, and these are guys that started the whole process of analyzing the US filings, company filings, are Loughran and McDonald. They created a dictionary in 2011. I think it was in 2011 when they published a paper in the journal Finance, which is a #1 journal in the finance field, with a dictionary of the 5% more used words in the 10 case. Now tell me, what is the super, this is very simple statistics. You just make a list of words that appear, the 5% that appear most commonly in documents, and then you make an explanation of those words. And that was the Journal of Finance paper. It's not rocket science. What was rocket science at that time is the technique to extract those words and to present them. But otherwise, it's just simple statistics. Not even that, it's just summary statistics and an explanation. But they created, and I will show you in a bit, a master dictionary that you can use for sentiment, to market sentiment.
What's 10Ks?
So the 10Ks, the companies are in the US have to file 3 times every quarter something called the 10Qs, and once a year a 10K. So this is all the financial statement plus the management analysis of those statements. And what are the perspectives of the company is what the management tells their shareholders, what is the standing of the company. And it's mandatory for public companies, for listed companies, once a year the 10Qs, and 3 times a year once a year the 10K, and 3 times a year the 10Qs. So it's the company filings. And they're all available. So this is something that you can download from the company website, you can download from the SEC, and you can download for the whole companies. And because it's in a server, you can make an engine that downloads all these filings. So what are the dictionaries of Loughan and McDonald? So they have, and these are example of words, because in the first category you have like 2,000. Negative words: loss, bankruptcy, indebtedness, felony, misstated, discontinue, expired, unable. You have positive words as well: beneficial, excellent, innovative. Uncertainty words, litigious words like breach, defendant, plaintiff, remain. Modal strong and modal weak are parts of the language that make something more strong or weaker. So if I say definitely lost or definitely bankrupt, is making that negative word even more stronger. But look, like here, the technique is very simple. I'm teaching the computer, using a dictionary, how to understand a piece of paper, a filing. So if I see the words always bankruptcy together, it's going to be something very bad. The company is learning that these words together mean something very bad. There is here the scholars in linguistics would tell you also that it's very improbable that you have something like a negative with a modal with a double negation. So you don't say that, for instance, we will never get into bankruptcy. That is very improbable. So the idea is that you have a modal strong with a negation, rather it goes in the same direction.
That's actually a very Russian thing to do, like this double negatives. I once had a sentence with 4 negatives.
So there is your advantage in textual analysis, how to analyze more complicated.
I think that this is an interesting approach, but it has to be really very related to how the language is structured. Because
absolutely. This is English. I'm talking.
Yeah, in Italian,
yeah.
Instead of having uncertain words like ambiguity and proximity, you could have a complete sentence getting the idea of ambiguity.
There is.
Judge, they like very much to have this kind of approach with long sentences and to say just ambiguity.
In Italian, a typical politician would start a speech saying, non possiamo non dire che no, which means we cannot say that we do not, and after 3 negations, non possiamo, we cannot, non dire, not to say that we do not. So after 3 negations, you are so turned around that now he can say anything. And that anything would be so ambiguous that cannot be really anchored to any statement. In financial statements, they are not politicians, so the language, and I will show you also how to analyze if the language is readable or not readable. That's one of the techniques. But so far, the idea here is to have dictionaries. You create a list of words that mean something together or in conjunction with the other. You can create your own dictionaries. And in fact, I use my own dictionaries to analyze contracts in one recent paper regarding the clauses, rigidity clauses, so more termination, more litigation, or more arbitration clauses. Second technique, unsupervised topic analysis. So I'm going to show you how to analyze topics unsupervised and in a supervised way. Unsupervised means you just throw the text and you only say how many topics are there. And the computer is going to select like silos of words that are more commonly linked together. I have to tell how many topics. So the technique here is I just, in the extreme is going, the end topics is going to be the number of documents. But we don't want that. We want to narrow. So I say 3 topics, 4 topics, 20 topics. A topic is a set of words that is in conjunction with the other. So look, for instance, the word Trump. Trump can be a person, a candidate for an election in a big country, or it can be also, I don't know which card is.
No, it's not. It depends.
It's a play.
Yeah, it's a play. Yeah.
It's a play. Yeah. So if the word Trump comes with spades, bridge, and trump, so it's more likely that it's related to the game, right? That I'm playing bridge. But if I find primary poll Trump, then is about the elections. And the software is pretty good in selecting. If I give a text.
It depends. Trump could be having the first spade in the inauguration of a new bridge.
The idea is structural topic modeling. Structural topic modeling, what tells you is identifies the words that come together, and then they tell that a specific text is 20% of topic A and 80% of topic B. It's not that I say this is a cutoff. It's 100%, it's a 1-0. In general, is a percentage. Then you can say, well, because 80% is much higher than 20, then this is about the elections.
How do you handle the fact that Trump is a common expression in English? So you sort of say, well, his knowledge of the subject trumps the other's experience. That's
so that
expression in English.
We would have to run it together, so probably more words would come here, not only 3.
Okay.
But in general, maybe in that case, the text would not be an 80-20, it would be a 60-40. And you will have still some discretion in how to put it together, if this is a different topic or it's a mixed topic.
But that means you have to identify all the cases.
Yeah, this is, here is a simple example of a word that is ambiguous, but the software is good enough to cluster it in 2 different sets, right? Because of this ambiguity.
Is that the software like a package for Python or?
Yes. Yes. And actually there are many. STM is just a general term. I'm going to show you what I did recently for ISNIE papers for the board of the Society of Institutional and Organizational Economics. So the society for the last X years, actually since 2008, they were collecting the abstracts and titles of the papers presented. Unfortunately, we did not have the full papers. So they were interested, first, which papers, how the topics evolved, and second, how they were, where they were published. So the number this year at the conference was 80%, that 18% of the papers ended up in publications. And that was done also using some textual analysis with the name and the title, searching in Google Scholar, where they were published, automatized. But the topic analysis was done using the title and the abstract. So we stamp the titles and abstract, drop neutral words like paper and show, because these appear everywhere, so you want to drop them off as a fixed effect. And then we use a technique called the latent Dirichlet allocation that clusters the topics. And the Dirichlet is a distribution type. I'm not familiar exactly with the math behind the model, but the idea is it clusters in a number of topics that you give it. And I will show you an example of 20 topics, 8 topics, 3 topics, and 2 topics. So 20 topics, if I classify this in 20 topics, and it would give the transact, cost. Why transact? Because this is the STEAM word. Transact, cost, market, product, agriculture, and I apologize because in the Mac it looks correct. Transact, cost, Mac, finance, investor. This would be transaction cost topic. Another topic, political regimes, and the order is not random.
These are all the STEM words, right?
These are the STEM words together. So when it comes together, I can say, well, if somebody is talking about transaction cost, market, product, price, agriculture, finance, investor, global, this is probably about transaction costs. Somebody is talking about politics, regimes, individual history, bureaucrat, Muslim. So this is probably about politics or political regimes. If somebody is talking about contracts, party, local, rent, violent, Indian village, so that was clustered as a topic of contracts. But 20 is too much to handle. So what about if I put 8? Would it be more clear? Well, it becomes that the topics here are evolving into institutions, governance, labor, for instance, corrupt effect, labor, crime, firm, wage, employment, and all the derivatives, study, find, employee, work, policy. So this is about labor.
Just curious, you assign these names to the...
Yes, well, this is done by hand. Why was it called labor? The software doesn't tell you that this is about labor. But once you see the words, say, well, this is about labor. This is about contracts. This is about litigation patents. So there is still some handling that you have to do by yourself. In general, it's about the most frequent word that appeared in that topic. Here, the order is not presented in a significant manner, which one is first. I will show you how it can be done also in a graphical way. But the word regular, regulation, market price, disappear more frequently. So this more arguably about regulation and competition.
So how about the ordering like vertically? Is the first?
No, it doesn't. This order, it is how the machine is throwing. And it's not about any persistence or a statistical frequency.
Are these 8 topics a subset of the 20 topics on the previous slide?
No, these are the same corpus of text,
Right.
and instead of saying 20, give me 8.
No, I understand, but say there was a topic in here, you then say there might be...
Very good question. No, very good question. The answer is no. It can be reasset in a different way.
So they're splitting the topic into 2.
There may be some overlap, but it doesn't mean that here it will be 2 topics, and here it will be 2. It will be 2 on somewhere 3. It may be, but it doesn't have to. What about 3 topics? Institutions, the same corpus. And you see, it gives you a different idea. And here, if you know the history and, of the society, and John can tell you that it was founded as the International Society for New Institutional Economics, renamed 2 years ago for the Society of Institutional and Organizational Economics. So one of the questions was, are the topics evolving into more organizational economics? If so, when clustering by topics, we should find more about organizations or organizational economics. So you see that institutions appear, market contracts, law and law contracts behavior.
But does the machine understand that, say, firm and market and product is something that has may have some connected sense, or they just go together in the text?
The machine doesn't understand anything. Okay. All it tells you, in as much, if you're, let me put it very plainly, if somebody is stupid enough to put together many random words for the machine, you are a very rational person that are putting all these stupid words together because of some reason. So for her, for the machine, this is the topic, although it doesn't make any sense in reality. So we are assuming that those words, that text makes sense in the first place. If the text doesn't make sense, for the machine, it makes sense somehow. And it would categorize, force 8 topics, or 3 topics, or 2 topics. So here is the slide where you show it's about institutions and it's about organizational economics. If I put 2 topics, what are the relevant topics? Will be clustered into these 2 mainstream. What is an unsupervised topic analysis? How can we visually present it? This is not mine. This is about constitutions. So there was a guy that got all the constitutions and say, what are the types of constitutions that we have in countries? So he had 3 types: the liberal type, the statistic archetype, and the universalist archetype. And I'm showing this as an example of a graphical representation of the words where the size of the word is also the frequency of appearance. So which words are more salient? And the rounded words are the words that are only appear in that type of document. So in the liberal archetype, we have the shall word. Shall appears very strongly. And the word parliament only appears in that, or is singular of that type of constitution. Whereas the statist archetype is more about revolution, socialist, nation. I mean, nation appears more frequently. But it's not only in this type of constitution, because nation also appears in the previous one. The universalist archetype, however, has more about rights and people, but the words that are singular are universal, charter, and world. By the way, these are mostly socialist countries. These are the liberal, like US, UK type, and these are constitutions of very young countries that they explain all the values in one. The example is for a graphical representation. How can you put all those topics in a way that one single slide would tell you which words are more salient?
Could it be about like 19th century language, 20th century language, 21st century language?
Well, the corpus has to be homogeneous. If what you want to do is an evolution of the language, that's fine. You can use this one.
You took all constitutions.
Yes.
And you say there are 3 kinds of constitutions.
Well, 3 kinds of.
What do you name them?
This is not my work. It's just to show how it can be graphically represented. How do you deal with language evolution? Probably you have to stem the words, or just take out words that are not used, were not used in the past, or that are very new. Unless what you want to analyze is the evolution of the text, for which topic analysis can be also a tool.
So these are the texts of constitution or what kind of
Constitutions. So the source here, the constitutions. The we, the people of America, I mean, at least in Argentina, we learn it by heart. Nos, los representantes del pueblo argentino reunidos en Congreso Constituyente, por voluntad y elección de las provincias que la componen. So this part, the preambles and the text of the constitutions.
So the constitutions translated into English?
Yes, yes. So again, very good question, very good question. Very good question. So constitutions are so well known that they are well translated. But you may have some ambiguity in the translation. So if I say, what word can be translated in two ways? So using a synonym in English. So the same concept from Chinese and from Russian was translated into English into two different words.
Corruption and facilitation.
Now, let's say...
Nation and Commonwealth, is that there is different things?
well, it's not exactly. But you may have a translation, for instance, nation and country. So we can say that you presuppose that the translation is good, but once you see that country and translation and nation appear in two different set of documents, but should be the same, then you can correct for that. That is quite a simple correction. But that is something, so this is still assisted. Or you can create your own dictionary supervised of synonyms. So country and nation would be the same, then please replace. Let me give you an example of a supervised topic analysis of the same corpus of data. So this is, again, the titles and abstracts of the past 8 conferences of ISNIE. Scott Masten in 2008, for his conference in Michigan when he organized, I was not there, maybe John was there. When people applied for the conference, they had to also self-identify the topic. So, which are your topic? Political systems, law, regulation, just to make the sessions. I don't have the data, what the people say about their paper. But what we did is classified according to these upfront given topics. So if we classified in these topics, we calculated the Euclidean distance between these topics once we set what is the percentage of each topic in each paper. And then you can force a graphical representation. So again, this is an example of how the topics evolved. So it was like from 2008, 11, 13, 14, 15, and this is the whole cluster. It's hard to read. This is not the purpose. The purpose is how you can show that certain topics are indeed together if they refer to the same topic, but some of the same topic are far away and more related to others. So here you see a little cluster of organizational markets in green together with a purple, which is development and transition economics. Also, you can see the percentage of the topics each year, or because there were not that many papers together in 2 years, and how a topic like development and transition economics and economics of transition is going down in time. However, organizations and markets are rising. And other topics like procurement and provision rose in 11, 13, but then went down. Maybe because after the crisis there were more papers about public procurement, and then the topic began again, came back to reverse to the average. So we have so far the dictionaries, unsupervised topics, supervised topics, which is very close to dictionaries. Another technique that you can use is how similar two texts are. So here, this is an ongoing study when I'm analyzing codes of conduct. So again, in the 10 case, companies file an exhibit 14 called the code of conduct. Code of conduct is how the company, in the bylaws, self-regulate their behavior. So we were analyzing all those codes of conduct together with company characteristics, and here is the hard data set. How do you complement? By the identification number, company identification key. Merged with financial data, but then how we analyze those codes of conduct. First, the hypothesis was that legal acts like the Sarbanes-Oxley, Basel II, and Dodd-Frank also influenced the way companies wrote their codes of conduct. So this is the hypothesis. So first we stamped these 3 laws and parsed into 3 word strings. And the same with the codes of conduct. And then you run how many overlaps of 3 words do you find? Because an overlap of 1 word is pretty common. But if I say Daniel is smart, probably this is not a random 3 word. If I find an overlap, then it means that I actually mean that Daniel is smart. And then you can run a different diff, how many overlaps before the law and after the law. With the presumption that the law, I change and I copy-paste what was in the law. So this was our hypothesis. That if you tell me in the law you should behave good, I will write, managers should behave good. I'm just copy-pasting from the law. This is an ongoing, so I'm not going to show any results. But you see the technique, that I can use a software prepared to see how much overlapping, and sometimes professors use it if students cheat. You can run an exam through a software and it will tell you how much overlap is with other sources that are in the net. Here it's a very simple technique of overlapping 3 words. You can do it 4, 5, how many overlaps. Of the stem word, again I emphasize the idea of stemming because plurals, the machine is very stupid. For a machine, price and prices are 2 different words. The stem word of price and the stem word of prices are the same, but not the whole word. Another example, and this is one of my favorite, readability. How difficult is a text to read? So we also, for the codes of conduct, we're running an index that is called the gunning Fox index. And gunning not because of a gun, it's because of the guy that invented it. And the simple formula is how many words are in a sentence. If I use a more complex language, my sentences are going to be longer. And how many complex words are in the total number of words. And a complex word is a 3-syllable word in a complex word. Times 0.4. Why 0.4? Because this is the calibration variable. And this formula yields how many years of education I have to be able to read a text. So if I have a Foggy index of 4, it means I'm in 4th grade. If I have a Foggy index of 12, it means I finished high school. 12 years of education. Very simple, but it yields you, if I don't want my shareholders to understand my code of conduct, probably I will write it in a very sophisticated, integrated language. If I want you to understand something, I would write in short sentences and with simple words. Let's do a readability with a political speech. And here, I'm going to use one candidate with any presumption. I'm just going to give you a textual analysis of a Trump answer. Okay? So let's see.
But isn't it un-American and wrong to discriminate against people based on their religion?
Yeah, but Jimmy, the problem, I'm for it. But look, we have people coming into our country that are looking to do tremendous harm. You look at look at Paris, look at what happened in Paris. I mean, these people, they did not come from Sweden, okay? Look at what happened in Paris. Look at what happened last week in California with 14 people dead, other people going to die, they're so badly injured. I mean, we have a real problem. There's a tremendous hatred out there. And what I want to do is find out you can't solve a problem until you find out what's the root cause. And I want to find out what is the problem, what's going on. And it's temporary. I've had so many people call me and say thank you. Now, if you remember, when I did that a week ago, it was like bedlam. All of a sudden, and you watch last night and you see people talking, they're saying, well, Trump has a point. We have to get down to the problem. The people that are friends of mine that called, they said, Donald, you've done us a tremendous service because we do have a problem and we have to find out.
Those may have been crank calls. Those may have been crank calls.
One of the things I find fascinating about Donald Trump is the way he uses language differently than other candidates for political office, especially President of the United States. Whereas his opponents and the political class in general seem hyper-aware that their words will be picked apart and used against them, Trump willfully disregards this fact. As a lifelong salesman, he has a huckster's knack for selling a feeling, even if the ideas and facts that underscore it are spurious, racist, or just plain incomprehensible. So I thought it would be illuminating to look at a Trump answer to a simple question. In this case, Jimmy Kimmel asking Trump whether or not it's wrong to discriminate against people based on their religion, referring to Trump's proposal to temporarily ban all Muslims from entering the United States. This 220-word, exactly 1-minute answer displays, I think, a range of the things that Trump uses all the time in his speech. The first thing to note is how simple this language is. Of the 220 words, 172, or 78%, are only one syllable, and often they come in a rhythmic series like a volley of jabs ending with one of his buzzwords.
We have to get down to the problem.
39 words, or 17%, are 2 syllables long. Only 4 words have 3 syllables, 3 of which are the word
tremendous, tremendous, tremendous.
And just 2 words are 4 syllables long. California, which he's forced to use because it has less syllables than San Bernardino, and temporary, which he swallows.
And it's temporary. I've had so many people.
This breakdown fits with a study done by the Boston Globe that put all 2016 presidential candidates' announcement speeches through the Flesch-Kincaid readability test to determine their respective grade level rankings. Donald Trump's speech came out at a 4th grade reading level. Now, for reference, Ben Carson came out at 6th grade. Hillary Clinton and Jeb Bush were speaking at an 8th grade reading level. And Bernie Sanders was way up in high school, a sophomore to be exact. Now, this isn't only down to word or syllable choice. It's about sentence construction, too. Trump favors simple sentences like,
we have a real problem. There's a tremendous hatred out there.
Rarely does he use complex sentences or independent clauses. He also favors the second person a lot of the time, addressing listeners directly with commands.
Look at Paris. Look at what happened in Paris. Look at what happened in Paris. Look at what happened last week in California.
Or implicating us in what he's saying as if we've already agreed.
And you watch last night and you see people talking.
He's really good at this, at framing negative response as an overreaction that was subsequently realized as such.
If you remember, when I did that a week ago, it was like bedlam. All of a sudden, and you watch last night and you see people talking, they're saying, well, Trump has a point. We have to get down to the problem.
Maybe the most important technique Trump utilizes, and he does this more than anyone I've ever heard, is ending his sentences with strong, punchy words. A lot of times he'll rearrange the beginning of a sentence awkwardly so that he can end strong. For example, here, it would probably be more natural to say, you can't solve a problem until you find out what the root cause is. But he brings the is forward to end on root cause. He does the same here. And it looks like that's what he was about to do at the end before Kimmel cuts him off. These final words are crucial for Trump. They're pointed and taken together sketch the theme of the entire answer.
Harm, dead, died, badly injured, problem, root cause, thank you, bedlam, point, problem, service, problem.
In some sense, it's these words that audiences remember, especially when the rest of his speech is incoherent. Like the best salesman, Trump keeps it simple. He repeats a lot.
We have a real problem. What is the problem? We do have a problem. We have to get down to the problem.
And he uses his favorite words over and over.
Tremendous, tremendous, tremendous service.
And he always seems to have friends who are part of the group that he's currently insulting, calling him up and thanking him for the privilege.
Many of them called me and they said, you know, Donald, you're right. We have a problem. I mean, look, there is a problem.
Donald Trump knows when to sound incredulous or forceful. He has good comedic instinct. You could even call him witty. But you can't call him smart or well-informed. The best salesman could sell you a TV without knowing anything about it, because the TV isn't what matters. What matters is you. And if you are an American citizen who, for years, has listened to politicians sound sophisticated while accomplishing nothing, you might just be primed for something that is everything they are not. But the next time you feel like Donald Trump has a point, do yourself a favor and look at his words.
Okay, Didier, I think the point is that we can analyze text. And by the way, I disagree that this is, he's not smart. He's incredibly smart in selling things. And he's probably one of the best sales people. And on purpose, he uses very plain words. It's not that that is what he would do every day. He does every day on training, on purpose, to sell you something. We can later on discuss on politics. Now I'm making textual analysis just only. Last point, merging with hard data. It's useless to analyze text just for the sake of the text. You should have a hypothesis, create a data set of text, and then which is going to be your other data set that you merge with. After this lecture, I'm going to show you how I use French data. But let me tell you a little bit how I used, oops, girlfriend coming up. What is coming?
You have to make sure you put the correct girlfriend on.
Yes, the correct one. Oops. Well, in my screen it's almost dark, but this was the last slide. Almost the last slide. What I did is I had a hypothesis that public contracts are different than private contracts. And regulated industries are different than non-regulated industries. So I downloaded all the contracts from the SEC, then analyzed their words in terms of contractual terms, classified the contracts into utilities, non-utilities, merging with words data set, which stands for Wharton Research Data Service. And then I got all the financials for the companies from the hard data set from words, from data stream and words. So how do you, and in the SEC, you only have the contracts, the text, and the identifier of the company, and the year of filing. And then I can get the hard data, what are the financials, what is the company sector, merging with the company characteristics from the Word dataset. So that's how you can get much farther getting a hard data set merged with that one. Other data set you can analyze with, for instance, speeches with characteristics of politicians, or characteristics of judges if you're analyzing their decisions. So always remember the hypothesis, what is that you are testing the technique, but then a hard data set. The last slide that I wanted to have for the last 10 minutes is a proposal. The proposal is the following, the exercise. Give me 4 things, and maybe we can have a paper together. A hypothesis, a text, that is going to be a corpus of text to analyze, a technique to analyze it, a text and a technique, a hard data set you merge with, and what is your expected result. As an example, my hypothesis was that public contracts are different than private contracts. Public meaning governmental. I was using contracts with the technique of dictionaries to classify it into more rigid and less rigid. The hard data is the municipal characteristics at this level, and the political contestability of the jurisdiction these contracts were signed in, how competitive the units were. This is hard data. The results, expected results, and the in facto results were that public contracts have more rigid terms than private contracts, and that rigidity rises when the jurisdictions are more competitive politically. Now it's your turn. Who wants to pitch an idea? A hypothesis, a data set, and an expected result.
I'm a little bit weak on hypothesis, but you have the universe of scholarly papers, and you have editors, and they have papers. And there are times when they become editors, and there are times when they stop being editors. So you have AR, and you have papers published in AR, under one editor, under another editor, before.
Okay, so what?
They might be setting the agenda. So the papers that get published in the AR might be topics of the papers published in the AR, might be a function of who is the editor. Let me give you an example, Bayesian persuasion. Before 2011, nobody cared about Bayesian persuasion. In 2011, two editors of AR published a paper about Bayesian persuasion. There's like now, sessions on the conference, Bayesian persuasion number 6,
Okay, so the hypothesis is an agenda building,
right.
Agenda of my research, which is not.
There are referees. There are lists of good referees in every issue of AR. They might set an agenda, right? Because they have papers, and you can get their topics, right? And finally, there are well-cited papers, not necessarily in AR. So do people write what editors want them to write? Do people publish what referees want them to publish? Or do they just...
Looks like something that can be done in textual analysis. So the topic selection would be something that can be done with textual analysis. Okay, and the hard data then you have to merge with some kind.
I think an interesting one might be to look at the correspondence between presidential speeches in different countries and changes in policy. My hypothesis is that in less developed countries, the executive is usually much more powerful than in more developed countries. So the President of the United States or President of France has less control over the agenda than the President of the Philippines or the President perhaps of Argentina. I'm not sure, I'm just guessing. So if we look at the State of the Union address, or some important address for that person for their whole term, say 4 years or 6 years, and then we look at textual analysis and we look at some index of, say, laws through Congress or Parliament, and the correspondence between the changes in policy in that country and the clusters of emphasis of the president versus, say, his predecessor.
So what is the hypothesis here?
The hypothesis is that you will see more continuity regardless of president in the US. There will be more divergence between actual policy changes and the speeches of the president in the US versus the Philippines or Argentina. Where in the Philippines or Argentina, you'll find more changes between regimes if there's a big change. So imagine in Argentina or the Philippines, you have two presidents back to back who have very different policies in terms of stated things. Then you will also find much broader differences in terms of past legislation or what have you.
Oh, so between speeches and legislation. That's the hypothesis.
That legislation will more generally reflect the change in the speeches in less developed.
And here the hard data set would be the political data.
Right, exactly.
Who is ruling, who is not ruling at each time.
And also whether the bills or whatever, or budgets, I'm not sure.
Yes.
So the problem is language.
Another proposal from students, participants. Yes, Nikita.
That was the thing I was thinking for a while. So there are online forums where people discuss the bribes they're going to pay for avoiding the military service. And
Again, can you...
Online forums where people discuss the prices of the bribes for avoiding military service, which is very common in Russia. And the discussions are sometimes, I mean, people really want to know like at least the ranges from which to which price, and it seems to be that the prices were evolving during the time. And they were responding as well to the anti-corruption campaigns, or roughly anti-corruption, but particularly actions against the...
Fine. Now the hypothesis?
So the prices are deterrents, basically detections, rate of detection. Once they, the public officials in those military services, they notice that there's somebody getting arrested, they update the prices. So basically, probably
and the text would be the forum, what they say, people in the forum, hard data to merge with?
Well, it will be another analysis on the on the cases which go into the media, scandals basically.
Scandals that you have like a list of scandals.
The region or like some locality, and then it's,
and the expected result?
The change in prices, and to see exactly how I mean
that prices change.
Well, the thing is that scandals normally also report the prices of the bribe that they got busted for. So you could also see the hypothesis like, are they busted for taking too much, and then this doesn't matter for the whole price, or are they busted for taking exactly the same prices, and then they like have to update because.
One thing that I would like to avoid or help you avoid is using a fancy technique and just creating a paper out of the fancy technique. So again, the hypothesis and the hard data you merge with are very important in supporting your hypothesis, not just only the capturing. It seems that it could be done, absolutely. I'm not sure what would be the hard data to merge with.
Does it always have to be the hard data?
Yes.
Because I saw some papers which like relatively need this hard data. Like this paper on the conflict influence on social capital, the conflict in Ukraine, did you use?
Oh, okay, I see.
For example, I mean, that's what they do, right?
We can discuss later on. Other ideas? So, yeah, Andre and then Julia.
Yeah, so might sound a little bit crazy, but we have data on how fast people move in cities by car. So we have data from, say, Google Maps or Russian analog, but in some of these maps, it's also possible to write comments.
Comments.
So, comments, yeah. So how do people feel in these traffic jams? So because we don't really know whether people go long distances or short distances, they can be, you know, they may have different satisfaction from roads. They have like more bad commands or less bad commands, whereas the traffic speed can be the same.
Okay.
So we could just compare how the
hypothesis.
People care not about the speed but about some other convenience. So kind of some expected results.
The text to analyze is the comments.
The comments, right.
Okay, and the data to merge with?
Hard data is kind of the speed of traffic.
Okay.
And so we could compare and say, for example, we can even have the weather data and say, in bad weather, people are really angry with the same traffic speed, say.
Okay.
So
sounds like doable. And good to comments are a homogeneous from a web page, a homogeneous text corpus that can be analyzed. Absolutely. Julia.
This is a rough idea, not well thought. I came up with it now. So in the US, when the natural disaster happens, then for some natural disasters you receive federal assistance, for others you don't receive federal assistance.
Okay.
So you could treat them as major ones, and if they are claimed major ones, then they receive federal assistance. If they do not receive federal assistance, let's call them minor. And then we can try to see what is the causal effect of federal assistance on, let's say, recovery of the I don't know, unemployment, GDP, whatever variables you could think of. What is the role of the federal assistance for the recovery?
And it would be done by the technique of matching, or you find major event and minor event, which are very similar in terms of
damages.
And then just to compare what are the recovery results out of these events. But then, of course, federal assistance might be a very endogenous object, right? So, for example, media coverage is something that might really affect whether federal assistance is given or not. Analyzing the news and
using media coverage as a covariate to see. Well, I was using. I think I discussed it with two of you. How the performance of hedge fund managers was affected by the news after the crisis. So this was whether Democrats or Republicans react differently to certain news when your president is in power. So absolutely to take the sentiment. That could, yeah, media coverage. I didn't mention it. I mean, it was in the slide, but I didn't mention it. Media, at least in the US, all the data is very easy to gather. It's just only 3 strokes that you do in Factiva, and you get all the news on a certain topic from the outlet of your choice. So I can ask, please give me all New York Times, Wall Street Journal, and Washington Post topics on articles on corruption for the last 10 years. And it will throw me a very standardized text format with the beginning, the time. Automatized means that you have tags where by textual analysis it's very easy to extract the date, the topic, and the outlet. And then using the market sentiment type of dictionary, you can see if this is very positive or negative, if it's complex or simple, and using those metrics as correlated with your choice, whether it is a major or a minor event. Okay, I think we have run out of time. Thank you very much. I will be